In a continuation with the atomic structure, now we are going to derive some relations for calculation of radius of nth orbital by using Bohr's concept. Now, in the Rutherford as well as in a Bohr concept, we know that the electrons are revolving around a nucleus. So, the force of attraction, that is a Coulombic force, is equal to or is balanced by the centrifugal force. So, if I consider this concept, is that Coulombic force between nucleus and the electron is equal to centrifugal force. And therefore, the electrons are revolving in a circular path. Any one of the force is greater, then either electron will fall into the nucleus or it will escape out. But it never happens. So, Coulombic force is nothing but 1 upon 4 pi epsilon 0. So, we call it as a K multiplied by Z, number of electrons as well as protons, multiplied by charge on the electron. The same charge is there for protons also, divided by R square, Coulomb's law. Force of attraction between the two nuclear charges is directly proportional to the product of charges, the values of charges, and inversely proportional to square of distance between them, and is equal to mv square upon r. Okay. So, mass of the electron, velocity of the electron, and radius r. Now, just I am making some of the simple changes. So, I am writing k into z into e square upon m into r, that is equal to v square. So, this will be equation number 1. Now, according to the Bohr's concept, why electrons are revolving in a certain selected path? Because it has a certain angular momentum which is integral multiples of h upon 2 pi. So, according to Bohr's theory, angular momentum mvr is equal to nh upon 2 pi. So, v is equal to nh upon 2 pi mr. This will be equation number 2. Okay. So, after comparing equation 1 and 2, we can write here as k into z into e square divided by m into r. K into z into e square upon mr. That will be equal to this one, we have to do a square. So, we have n square h square upon 4 pi square m square and r square. So, for radius, if I am writing r is equal to n square h square upon k into z 4 pi square into m. So, we are taking this side. So, this become, and this is coming over here. So, r square I am keeping over here only. So, here 4 pi square m, because m get cancelled. So, r is equal to n square h square upon kz 4 pi square. So, I am just writing this way. We know h square, we know k, the value of k 1 upon 4 pi epsilon 0. Then 4 into pi square into m, mass of electron. Now that will be multiplied by n square upon z. Okay. Now this value or this part remains constant. Planck's constant 3.14, mass of electron 9.1 into 10 raised to minus 31 kilogram, and if we calculate that value, you will get the answer R is equal to 0.529 or 0.53 into 10 raised to minus 10 meter. So that becomes angstrom. 1 angstrom is equal to 10 raised to minus 10 meter. So 0.529 into n square upon z. Okay. Unit for this is angstrom. So if I consider for hydrogen atom, n is equal to first shell, z is equal to 1. So R0, we call it R0, that is radius of first shell in hydrogen atom, and that is equal to 0.529 angstrom. So radius of other shells in other atom is this times 0.529. If you see carefully over here, you can observe that R is directly proportional to n square. So radius increases with a square of shell and inversely proportional to z. Now this plays a very important role when we are dealing with periodic properties, periodic table. As we move across the period, atomic number goes on increasing, number of shells remain constant. So atomic size goes on decreasing. So this plays a very important role. Now if we go down the group, atomics, this is increasing, but number of shells are also increasing. So this effect is more. Therefore atomic size goes on increasing as we move down the group in a periodic table, which will discuss. So quantitatively we can explain this way. This is a Bohr's concept. Okay. Now in IIT there will be problem based on this formula. So we have to remember this one. No need to remember whole this thing, because they may ask you a question like this way: calculate the radius of second shell of lithium. Now it is quite simple problem, but there may be some comparison between two atoms, and in that case we need to calculate radius of one atom. So this way there will be a question based on that. Now from this we can calculate velocity. How can we do that? So the second thing is velocity of electron in nth orbit, present in nth orbit. So how can we do that? If we do this way, divide equation 1 by 2. So what we are getting? V is equal to, so V on one side, same side. So V is equal to, we have K Z E square upon MR divided by NH upon 2 pi MR. So velocity of the electron is equal to, we have this M and M get cancelled, R and R get cancelled. So we have K Z E square multiplied by 2 pi upon nh. So velocity is equal to k e square 2 pi upon nh multiplied by z upon n. So n is already there. Okay. Now this is constant, this is constant, this is constant, this is constant. So that constant value is coming at 2.18 into 10 raised to 6 multiplied by z by n, and here the unit is meter per second. Unit is meter per second. So this will be velocity of electron in nth shell. So velocity is equal to 2.18 into 10 raised to 6 z by n meter per second. So velocity is directly proportional to atomic number and inversely proportional to number of shells. So for an electron present in first shell of hydrogen atom, so what will be that value? That value becomes velocity is equal to 2.18 into 10 raised to 6 meter per second. I call it as a V0 now. V0 means velocity of an electron present in first shell of hydrogen atom. This way now we can calculate radius as well as we can calculate velocity of the electron. In our next session, we will be calculating energy, total energy of the electron.